Hello everybody, welcome back after the coffee break. So everyone is fine?
Yes.
You feel comfortable?
Great. Yes.
The room temperature, facilities, everything?
Yes.
Good?
Thank you.
Okay. If you feel not comfortable, please let me know. Okay? So let's start our new chapter, which is Geography meets Geometry. A small review before we start. In the earlier chapter, we have added so many data, okay, using the Add Data button to the MXD file, right? Roy, from where did you add your data to the MXD?
We added some feature class from
JDatabase. Right, JDatabase. So we added data from JDatabase. Greta, from where else we add data from?
From shapefile.
Shapefile, right? Shapefile. Another example.
From folders.
From folders, like what? For example, the
image.
The right image. Okay. 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 Perfect. So we use many different sources, okay, to add our data. So we used different layers in the table of contents. In this lesson, we will learn how we can store this data. Okay, where did they come from? Okay.
Okay.
So the learning objective of this lesson is to describe the two main geographic data formats used to represent the real world features. Okay?
Great.
Let's make small brainstorming before we start. I want from you, Ahmad, to give me an example, a real example of geographic data.
A parcel.
A parcel. A parcel is a data that I can represent it in GIS,
Yeah.
right? Another example of geographic data, Greta.
Elevation.
Elevation data. Another example, Muhammad, but another question. What kind of data you are working with at your organization?
Soil type.
Soil type. Very interesting. Can you see the
Yes.
what I fine here?
Yes, fine.
Soil type. Okay, good. Another example like street network, okay, and parcel, as Ahmed said, flood and when. Have you ever asked yourself how can we represent these kinds of data, or these kinds of real geographic data in GIS? This is the question. Here we will learn how we can store this data. So we can store data, as we said, we can store data into two types. The first type is vector data. The vector data is a shape-based view that consists of three geometry types. We learned that three geometry types before, right? So, Ashraf, can you tell me what are the three geometry types?
Points,
Lines, and
polygons.
good, perfect answer. So, vector data is good for representing discrete objects to get more accuracy in the data, okay? To get more absolute in the data. So, for example here, polygons, okay? I can represent the states and counties as a polygon feature. So, vector data is good for representing man-made features. So, the counties or municipalities or districts, these items are created by man. They set the boundaries for every district. They set boundaries for every single state. Okay, so they are man-made features. Another example of man-made features: street network. It's a man-made feature. Bridge, tunnel, everything related to transportation.
Okay.
Okay, fine.
Yes.
Yes.
Question?
No.
No.
So, in addition to the man-made feature, vector data is good for representing natural features like peaks and rivers. So in this example, we represent the peaks as a point feature, and we represent the river as a line feature. Make sense?
Yes.
Okay. So Any question before we go to another slide?
No.
Okay. Here I have an image. It's a satellite image of a specific area. It consists of so many features, of real-world features. Okay, Muhammad, can you give me an example of real-world features for? I can represent it as a polygon feature. Polygon?
Maybe the footprint
Footprint of what?
for the building.
Okay, I can represent this as polygon.
Yes.
Okay, perfect. Roy, another example of representing a line feature.
Okay, we have a street in the middle of the
Street.
map.
I can represent a line feature. Good answer. Greta,
Yeah.
for point feature,
Maybe the trees.
the trees, yes, right here, for example, and right here, I can present it as a point feature. So, from this slide, of this image, I can connect my vector shapes to a real place, as we see here, as we see when I represent the point. So, when I want to digitize a point on the image, okay, I have to give it a pair of XY coordinates. Okay, so I'm giving it a pair of XY coordinates. The same idea for the line. Okay, but the line is a series of XY coordinates. So I start from this point, I'm giving specific XY, and I finish at this point. Okay? Fine. Polygon is a closed shape. So I have to start from here to define an XY coordinate from this point, and I should finish at the point that I started from. Okay, so it's a closed shape, a closed mass, closed polygon.
Okay.
Okay? Any question?
No, it's
Make sense?
Yes.
Okay. Let's move. Okay. So some features are good to represent it as a vector data, while others, while other features that has a continuous phenomenon or continuous surface is better to represent it as raster data. So this is the second type of how we can store data in GIS. When we add the satellite image to our MXT in the previous chapter, when we add, okay, we call the satellite image, it's a raster data. It's a raster data. Raster data is a cell-based view. Okay, it consists of a matrix of square cells, as we see here. Matrix of square cells. Okay, an example of raster data, like elevation, because it's continuous phenomenon. Okay, it hasn't bounded to represent it as a vector data. Okay, imagery, like a satellite image, aerial photos. Another example, vegetation. Ashraf, can you give me an example of raster data?
For example,
Continuous
yes.
phenomenon.
Like
What do you think?
wind.
Wind, exactly. Can you?
Temperature.
Temperature also, because it's continuous phenomenon.
Ah, okay.
It hasn't boundaries to represent
Yes,
it.
Rainfall.
Rainfall, another example, right? Good. Great. Okay, so here, the examples that we gave earlier, okay, we can categorize them. This database shapefile and parcel, okay, we can consider them as vector. Good. Good. So it's vector data. Satellite image elevation data, soil types, Ashraf.
Raster.
It's a raster data. Perfect. Perfect. Good. Okay, any question for now?
No.
Good. So let's move on. Raster data structure. What is raster data structure and what is consisting of? Raster data structure is consisting of matrix of cells, as we said earlier. Each cell stores a single value, measure, count. So it depends on the data that I'm using. So I'm using, for example, rainfall data. So it stores value of double or float numbers like 2.1, 2.3. Okay. While if I'm using elevation surface, okay. Let's consider, or let's assume that this raster data is for representing elevation data. This is a real structure. This is a real structure of elevation data that is presented in these colors. Okay, each cell has a value. It could be integer, it could be double, whatever. Okay. So number 7 here